All right, so hopefully you guys can see my screen. So my name is Andy, if you don't know, and today I will be giving you a scuffed introduction to how to use Git and GitHub. So since earlier, like a couple seconds ago, actually, we just talked about how we released the project spreadsheet, and since this club is mainly for you guys to not only develop these technical skills in computer science, but like actually use them, and you'll use them by doing stuff, which is by making projects. So if you guys aren't getting GitHub, you'll be able to code more collaboratively with each other, and it just improves your workflow. So that's the benefit of learning Git and GitHub. So basically, you don't even need to know how to program, but you can learn how to use this. These are basically tools to help you program collaboratively with others. So the objective of this workshop is to teach you guys how to navigate on GitHub and or use GitHub Desktop or the terminal to improve your workflow when you guys code. So by the end, we'll hopefully cover what repositories are, what pushing and pulling are, what committing is, what branches are, what pull requests are, merging, and forking. So if you don't know what any of these are, or maybe you've heard of them, hopefully by the end of this workshop, you'll have an idea of what those words mean. So the first question is, what's Git? So Git is a version control system that's built by Linus Torvalds. If you guys don't know who Linus Torvalds is, he's a very famous computer scientist. He's the person that invented Linux, so that's pretty cool. And well, what's version control? It's basically a very, very fancy save as for your code. So think of how when you work on projects, you usually have to save it multiple times whenever you catch an error. So let's say the first time around, you convert your doc into a PDF and then you read it over and then, oh wait, I messed something up. So then you resubmit it and it's like you have to call it final like report or something like that. It's kind of like this where you basically have instances of your code that you can save and you can kind of like backtrack through. So let's say like you work on your code, it's all good, and then one day someone else works on the code and then messes everything up. You can basically do a really fat Control Z and go back to that initial point in your code, or like before it was messed up. So Git allows for someone to basically track changes throughout source code during software development. So it allows for you to collaboratively code with each other. So that's really nice. And with Git specifically, you usually use the terminal commands to like create repositories, make different branches, and merge them together. And GitHub is something completely different, but also similar and at the same time. Basically, it relies off of using Git software, but you could use GitHub without any knowledge of Git, or you can use Git without any knowledge of GitHub. So um, for the purpose of this workshop, we'll be introducing you guys to both of them because I think it's beneficial to learn how to use both because you'll see in a little bit. So GitHub is basically an online platform for version control and software development that uses Git, like I said. And basically it's like a website where you can kind of like look at other people's source code, or you could like update your own source code and you could go back and look through it. Like it's kind of hard to describe in words, but when we go through our activity later, it'll make a lot of sense to you. So why should you care about Git and GitHub? So if you ever plan to develop software for a company, chances are you're going to have to use some type of version control system. Sure, right now you might be working on your own personal projects and you might be doing like pair programming or whatever, but when you start working at larger scale companies where you have to work within a team and there's like sub teams within those teams, you have to be able to do version control because you'll be working on different types of code, different types of like programs. It's not going to be limited to just one file, basically. You're going to have a bunch of files, different folders and everything. Um, do you want to work collaboratively but use something other than Google Docs as an IDE? Yeah, I mean, I used to code like with my partner, like at Boeing on Google Docs, and that was an experience. So basically, if you answered yes to any of those questions on the slides, then you should probably care about Git or GitHub. If you don't, I'm sure you'll get some benefit out of caring. So uh, here's a general overview of what Git and GitHub kind of are like. So first off, a repository is basically a storage location for like files basically. And this repository can be local, as in it could exist on your local machine, or it could exist like online through some website like GitHub. So these repositories contain a bunch of different files. So in a typical like, example of workflow, like I could be coding on my project and I could push my code to a repository, meaning that I worked on my code and then I want to update the files that exist within that remote repository. And I want to say, hey, I made these changes. Please update it on this website so that if anyone else goes to that website and wants to pull or yeah, pull code from that repository, it'll be updated for them. So in step 2, Chester pulls the code down from the repository to work on it. So I pushed my code up to the repository. It's updated now. Chester can now, either using Git or GitHub desktop, he can pull that code from the repository into his own computer. So he has all the updated changes on his own system. He can make his own changes and then push that code back to the repository. You can make a pull request or whatever, and that cycle will keep going back and forth. Except like obviously if you're working on like a big project, you might not just have 2 people, you might have a bunch of people working on the same repository. And then that's when like branching gets involved. So branching is basically how you make, I guess, copies of a repository, like that's really like how I could best try to describe it. So in GitHub, there's this thing called a master branch, but it's also called the main branch. You can think of it as a main master branch. It's like the main branch basically. So you can basically work on your code like and develop your code, but then eventually you might reach a point where you want to do something, I don't know, maybe risky, or you might want to implement some new feature into your software to see um, to like try, basically you want to make changes to your software, you want to make a new version. So the safe route to go would be to create a branch. And a branch is basically you copy everything that was at that instance into its own like copy. So that you can do whatever you want to it and it won't affect anything that was on the master branch. Uh, so in this example, Chester pulls down his or makes a branch out of the current instance of the master branch, and he starts working on it. So each little dot here represents changes that he made. So while he's doing this, obviously might still be developing stuff on the main branch, but he can basically do whatever he wants, and then he could merge that branch back to the main branch. So all the changes kind of get merged together. Sometimes there might be merge conflicts, and that's something you might have to resolve manually, but typically Git and GitHub are smart enough to be able to recognize where the changes were made and how to like overcome those conflicts. So it's pretty smart. It basically does everything for you. Sometimes you might have to do something yourself, but merging is pretty useful because let's say Chester worked on a feature, it didn't work, so he can just delete the branch, just move on. Or the feature works and he wants to incorporate it back into the main program, he can do that easily just by merging the branches together. And then before he merges that, however, he usually has to make some type of pull request. And a pull request is basically a request to the main branch saying, hey, can you look at my code and check if it's okay before I merge it onto the main branch? Typically, like you could have the settings in GitHub to where you don't need to, you can make a pull request and instantly merge it, but usually you want a couple people to check your code to make sure it's all right. And then they can do that by making their own copy of the repository, running some commands to check it, or they can do like unit testing on it. And they usually approve, okay, this is good. Or maybe it's like, hey, you didn't do something right here, or hey, this can cause like a bug. Please fix it before they accept your pull request. So that's basically that. So this is just another picture to depict like how, I guess, like complicated the branching can get. So normally if I don't know if any of the projects we'll be making within this club will ever get this complicated, but you never know. If we decide to make a crazy project or something, basically you can have a bunch of these different branches. So you can have like a master, this is the master branch, you can have a hotfix, release, develop, feature, and different people or different sub teams can be working on those features. And then they can slowly merge into other branches, and then bugs can get fixed, features can get implemented, and then eventually you'll merge it back into the master branch where a new version can get pushed out. So that's something to consider, something neat that you can do with GitHub. So without further ado, let's jump right in and make our first repository and get an idea of what exactly branches are, what committing is, and what a pull request is. So I didn't make this myself. This goes to GitHub. If you ever make a GitHub account, this is like the first thing they usually make you do. So normally when you start a programming language or you learn a new programming language, you usually print hello world. This is kind of the same thing. It's kind of taking that tradition of printing hello world for the first time, except this time you're making a repository called hello world. So if you just look it over, we're going to learn how to create repository branches, then pull requests. So cool, basically what I just said. So the first thing we're going to do is make a repository. So we're going to go over here to the GitHub, and what we're going to do is we're going to click on this little, I think there's a plus sign here. There's a new button here. You're going to press new, and then you're going to be taken to this screen where you get to decide what your repository name is. So let's just call it Hello World, just because that's what the guide told us to do. So the thing about repositories is that you can't put spaces in them. So what they usually do is replace a space with a dash for you. So just a little fact for you guys to know. You can add a description if you want. You can add a README file where you basically, if a README file basically lets people know whenever they visit your repository, hey, here's what's going on in my repository. Here's what my program is. Here's what it does. Here's how you download it, whatever. Let's look at the guide and see if it wants me to make a README. So they recommend making a README, so why not? Let's do it. So we'll add a README. Cool. So a git ignore basically tells you what files you want to ignore whenever you either make a repository from existing files, or when you're like trying to add files and commit them, you want to usually ignore like changes to a file or just completely ignore some files. That's more like one of the more like meticulous things, so we're not going to really worry about that right now. We'll just worry about the README file. So we made the new repository. We initialized it with the README. So the first thing we do is we're going to hit the create repository button, and we should be taken to a different screen. So boom, now we're taken into our repository. So here's our repository, pretty cool. This is going to be where all our files are going to be, and here's where the README is. It's always going to be at the bottom beneath all the files. So if like a visitor were to show up to your like page, I guess, this is what they would see. They'd see your README and the list of files or some folders. So the first thing we'll do is we'll make a branch. So this is basically talks about what I talked about earlier, how there's a main branch and you can create branches and eventually merge them back into the master branch. So for the first thing we'll do together, how about we'll add a file. So we'll click on the add file button here. We'll create a new file. Let's call it hello.txt. And we'll just say, hello, my name is, like your name, and we'll just add a new line saying like, I like computer science or something. Okay, so we added 2 lines, just some random text. And if we scroll down, we could commit our new file. So committing is basically saying, save my file or save the changes I'm about to make. In this case, we're going to be saving a change to the repository saying I'm adding this new file. So you could specify what the description of your commit is or what your change is. So you can just say I created a new text file. It could be anything really. You can add a description if you want, don't really need to. And here at the bottom, you can see that you have 2 options. You can commit directly to the master branch, or you can create a new branch, and that's where you can start like doing things on your own without affecting the main branch. For now, let's just commit directly to the master branch because we don't really have anything in our repository to begin with besides like a README file. So we're going to commit this new file. And now if you look at your repository, you'll see, okay, I got an additional file. If you click on hello.txt, cool, we have what we wrote. So good for us. Let's say this was some fancy project that we're working on and we want to create a new branch to make changes without affecting the main branch. So what we would do is we click on the master like branch thing, and this little Y thing is basically the branch button. So with here, you can create a new branch by literally typing what you want to call your new branch. So let's just call it new branch because why not? Call it new branch, and right here we get a button saying create branch, new branch from master. So from the master branch, so splitting from the master branch, I want to create a new branch where I can start working on my own changes to the code. So I click on that, and wow, I'm in the same exact files, right? Because what I basically just did was I made like an entire copy of what the main branch had. So now I can start working on my own changes without affecting the main branch. So if I click here, you can switch between branches. So I'm in the master branch now, I switch back, I'm in the new branch. So we'll do a couple of changes here. So the this little notification that says this branch is even with master basically says that I compared master and new branch and there's no changes. So obviously because we didn't do anything yet. So why don't we create a new file and we'll call it, I don't know, you can call it anything you want. I'll just create something. I'll add something, like it can just be gibberish, doesn't really need to be anything, and then I'll just commit it to, I will commit directly to the new branch. So now my new branch has the file something.txt, and if I go back into my master branch, it's not there. That's crazy. That's so crazy. That's because we're on a different branch. So if you guys remember, you guys can make any changes you want once you make a new branch, and it won't affect your master branch. It doesn't know anything about the files or the changes that you made on the different branch. So if we go back to new branch, we can go to, I don't know, hello.txt. We can edit it. We can do whatever we want. Like, oh, that's not right. Okay, we can go here. We can say like blah blah, like Shrek, and then we can say like added Shreks for my changes. So I commit directly to the new branch. So if you look at our code or our text file, this is in our repository. So we're in the master branch right now. We go to hello.txt. There's nothing there because everything we did was in the new branch. So we switch to new branch and you go to hello.txt. You can see all the changes we made. So that's pretty cool. So you can kind of get an idea of how this will help you code collaboratively because let's say I was coding with David and I was working on a different feature and I didn't want to possibly mess up his code. I would make a new branch and maybe add my other files or make changes to the main program. And that way it's a safe way to test things out without messing anything up. So I think that kind of covers branches. So we did our branches. And now we made our branch. Now we commit our changes actually. Now we'll make a pull request. Okay, now we're getting to the cool stuff. So if you ever, I don't know, like look at programming memes and they talk about like pull requests, now you know what a pull request is. It's basically a request to merge a branch or to like approve of someone else's changes. So the thing about pull requests is that if you're working on a repository with someone or some program, you could add contributors. So I can just add Whitney or Tiffany or David or Min as a contributor. And then when I make my own changes, I could basically create a pull request and like ask them, hey, can I merge my changes back to the main branch? And then they would look through my code, leave comments if they see anything that's wrong, and then they could just approve of my merge request and then or pull request and then merge the branch. So right now we'll press compare and pull request. So right now we want to make a new branch or a new pull request. So this is the title of your pull request. It could be like honestly anything. They said new branch, so we'll keep that. And then also you'll see right here, able to merge. Able to merge basically means GitHub will be able to tell the differences between the old files and the new files and make the changes pretty smoothly. If you had any merge conflicts, meaning that some lines were like I guess unoriented or like disoriented and they're not like lined up anymore, you'd have to go in and manually like see what changes you'd have to make. So I'm going to create a pull request and then I can look here. So I made 2 commits here and right now I want to basically review the thing. So if I make, this is a pull request. Let's say I sent my pull request to like David. If David opened up and checked pull request, like right here in the tab, here's like existing pull request. He'd click on this and he'd be like, okay, here's what Andy did from the main branch. Here's the differences that he made. So he'd click on this and review what I wrote. So the little green things and like little plus signs means he added this line into this file. So you can review changes. You could leave comments saying like cool stuff or something like that, and then you could comment that. Actually no, commenting is usually for like telling people what they did wrong or what they can improve. So that's, I guess that's what we could do, but I don't know if I want to do that. Wait, I can't approve my own pull request. No, wait, I could just like send it to someone. But David, do you want to approve my pull request? David? Okay, it makes sense, but what you could do is you can just merge. So hopefully you guys get the idea of If someone else was looking at this, they'd be able to approve and request changes saying, please change your code. I mean, that's as simple as I can put it. So you look at pull requests, you click on this. David looks through this, looks good to me. Merge pull request, confirm the merge. So now you merge everything. Normally you delete the branch because once you merge it, there's no point keeping the branch. You could keep it if you think you might need to go back to it. I'll just delete my branch because I don't think I need it. Now I go back to my code. I look for my branches. I should only have one branch, and that's the master branch. And if we look at our files, the saves successfully changed or stuff happened. So here's our new files, and that's how you merge. So I think that's all they wanted you to talk about. I don't know if my explanation was good enough, but if you read through this article on your own time or you go step by step, like if you have any questions, chances are this will answer your questions. So that's how to use GitHub. That's just the basic like introduction to how to do that. So obviously, if you look at how we did things like just now, like we had to type in like directly into GitHub, like what we wanted to change and stuff. And that's inefficient because normally if you're coding, you'll usually be using some like IDE, like like Visual Studio Code, Visual Studio, Atom, Sublime. You'd usually be using your own IDE to write your code. So obviously you're not going to want to code within GitHub itself because you're not going to be able to run and compile your code. So how would we be able to, I guess, edit our code in our own IDE, but still utilize the really good features that GitHub offers to us? So we come in and we ask ourselves this question. So what if I don't want to log into GitHub and then copy paste my code every time I want to make a change? You have two options, and I kind of briefly mentioned them earlier during this presentation. You can either use the Git bash terminal, where you could use the terminal and automatically, I guess, add and make commits, make branches, and merge them. Or you can use GitHub Desktop, which is a very, very user-friendly version of GitHub, but like an application of it, like a little application where it syncs with the files on your computer and it tracks the changes automatically, and you can like you can pull automatically, you could push it, and then you can make a pull request. Like if you don't know what I'm saying, like I'll show you in a little bit. So for starters, we'll start with GitHub Desktop just because I think it's really beginner friendly and it's so easy to use. Like you could, if you didn't understand anything I just said, like you could totally still use this. It's so good. So the first thing I will do is I will open up GitHub Desktop. Oh wait, I need to share my screen. Okay, share screen. So can you guys see my screen? Yes, David? No? Somebody? Please?
Yes.
Okay, cool. So
Yes.
I was messing around earlier and I was making random repositories. So basically when you download GitHub Desktop, you're going to have to log into GitHub. And then from there on, after you log into GitHub, it's going to sync with GitHub and your computer. So it basically allows your computer to interact with GitHub without going on the website. And you can just do everything from within this this application, except pull requests, I think. I think you have to use the website. But like there'll be a button that says, I want to make a pull request, and it'll send you to the website. So the first thing we're going to do is we'll just make a new repository. So I'll call it GitHub Desktop. GitHub Desktop. Wait, no. File. New repository. And I'll call this GitHub D example. So for desktop. So I want to store this in a file that I made. I just called it GitHub Desktop example, just because I wanted to keep it organized. So I'll create my repository. And this is the same thing as when I made my repository before. So now I have my repository. And I have 0 files because I didn't put anything into it. It's just basically a folder that I made on my computer. So this is what you would call a local repository because it exists within your own computer. It's not accessible to the world. So in order to make it accessible to the world, what we're going to do is we're going to publish this on GitHub. So we're going to click on Publish Repository. They're going to ask for the name. It's going to ask if you want to make it private. For this case, I'll just make it public, and I'll just publish the repository. So this is going to communicate with GitHub servers, and it's going to make this repository on your account on GitHub. It's going to push everything that you have and push it to the website servers. So now we have our actual repository. So if I go back to GitHub and I go back to my account, I should see a new repository pop up. And it's right here, it's GitHub D example. So through using that application, I was able to create a repository from GitHub desktop. So that's pretty cool. Now I can make my own changes and do stuff with it. So I think what I will do is I'm going to open this up in Atom, because Atom is a pretty smart IDE because it can communicate with Git and GitHub for you. So I'm going to wait for that to open up. So I opened up Atom and now I am waiting for everything to load. Okay, cool. So if you look on the left side, how do I just hide this? If you look on the left side, you can see that I have my repository, which is GitHub D example, and you have this folder called .git. You don't need to care about .git at all. It's really an invisible folder, and it basically just has the necessary files that Git needs in order to do its magic. So we'll just close all this stuff. Right now, I want to go into my repository. I want to make a new file. So I'll call this hello.txt like we did previously. And now we're going to start typing stuff. So I can say, you know, hello, my name is Andy. I like Shrek or something. I can save it now, and then if I go back to my GitHub desktop, it automatically tracks the changes that I made to those files that I made in the repository. So that's pretty neat, right? So I made my changes, and you're like, okay, you made one change. What do you want to do? You can commit it to master. You could make a new branch. For now, we'll just commit straight to master because we didn't put anything in our repository. So I'll commit to master. It's in my master branch. Now, the thing is, this really important concept of a local repository. I just committed to master, but I did that on my main, like my local repository on my computer. So like if I go to GitHub right now on my like Chrome and I refresh it, there's not going to be anything. There's not going to be a hello.txt because I never pushed it to the origin or the remote repository. So right now I made my changes on my local repository. In order to make the changes and save it on GitHub servers, what I have to do is I have to push origin. So origin is basically the repository or the name of or reference the main repository we made on GitHub's website. So if I click on push origin, it's basically going to push all the changes I made within my local repository and save it to my remote repository. So it's doing its magic. Cool, cool, cool. Now I go here and I refresh it, and hopefully I should see a hello.txt, which I do. So I did that, and let's say I was working, or someone else was working on this. They were doing whatever. They added a new file. They called this like my file.txt, like hello, and then they committed the file to master branch. So someone made a change on the remote repository, but the thing is, I'm still on my local repository. I can't really like see those changes unless I go to github.com, which I don't want to do. So in order to do that, what you're going to do is you're going to pull. So similar to how we just pushed our changes to the remote repository, what we're going to do is we're going to pull the most updated version of the repository onto our local repository so we can make our own changes. So we press fetch origin, and what that would do is that would grab everything, and then we can just pull it. So it fetch the changes, and now we can pull it and save it onto our local repository. So I pulled it, and hopefully now if I open up Atom, I should see a new file in my directory, which is called myfile.txt. So that's kind of an introduction to using GitHub desktop. You could make new branches pretty easily, like, you know, like new branch, press that, new branch, create my branch. And now I could publish my branch, make sure it's on the GitHub website. And then it's fetching origin. Okay, we're waiting a little bit. Okay, our branch is now on GitHub. So if I go back, refresh, and then click on branches, I should see a new branch, which is really cool. And I can make those changes to my branch, obviously, like Shrek. Like I can like make any changes I want, like pretend I'm working on a piece of software. And you can see the orange here basically means you didn't save these changes or you haven't committed them yet. So that's basically what the orange says. You go back to GitHub desktop. Okay, it tells you all the changes you just made. I just made all these additions. Cool. So I'm going to commit to new branch. So I'm going to commit onto the branch I made separate from the main branch. I committed it. And now here's, okay, I'll push to origin because why not? But here's where like it's really, really nice to have some type of application, whether it's Git or GitHub desktop, because now if I switch branches, it automatically changes. So like, for example, right now I'm on my new branch, right? So if I look through these files, I have like my Shrek stuff, I have my hello, whatever. If I go to my GitHub desktop and I switch to my master branch, it automatically updates every single file. So if I go back to my branch, Shrek's gone. So like that's how powerful GitHub desktop is, because it can make all those changes and give you those different instances of the same files just by like literally pressing like two buttons. So that's pretty neat. So that's GitHub desktop. And that's where I think that's a really good place to start. So if you want to just use that, I would recommend using that because that's honestly what I would use. But if you're feeling like super spicy and I don't know, you want to like you have like the urge to impress your 10th grade biology teacher, then what you could use is terminal. And what the terminal is it allows you to use git commands through a Linux interface. So if you ever use Linux like in Cyber Patriot, like then you this should be pretty easy for you. Like it's somewhat faster because you don't need to use your mouse to click on stuff. You can type everything. So I'll try to give you guys a brief introduction to using like Git terminal as well because I think it's nice to know. So if I go back to my desktop and I go to Git example, I have an empty folder here and I want to make some type of repository within here. So what I'm going to do is I'm going to, okay, first things first, you need to download stuff. Like you need to literally download Git onto your computer and it's going to download a terminal for you. So I've already downloaded that. So eventually you'll, okay, if you decide to do this, I'll probably like show you a YouTube video or something, but I'm sure you can figure out yourself. But assuming that you've downloaded everything, here's how you would get started with what I just did on GitHub desktop. What you would do is you'd git bash into your folder, and normally you have to set up some type of Linux like account or whatever. I already did that. So this is basically a Linux terminal. So you can use like your Linux commands. If you're a Mac user, it's the same exact thing. Mac terminal uses Linux commands. So you can use ls, there's nothing in there to show, but like what I could do is um, first things first, actually, nah, I'll do that. So first, let's just add a new file. So in Linux, that would just be touching. So touch, and we'll call it like hello.txt. If I refresh it or don't refresh it, hello.txt was created within my folder. I can open that in Notepad and say, hello, my name is Andy, you know, blah, blah, blah. I can save those changes. So now I have a folder that just has a file in it, basically. So that's cool, but now I want to do Git stuff with it. So the way I would do this is I would use this command called git init. And what git init does is it initializes like a local repository onto your own computer. So I press git init and it says initialize an empty git repository in my directory. So cool. And if I try to turn on hidden items, you can see that there's an invisible Git folder, which we saw previously when we were working with the Atom IDE. So cool. But like I said previously, this is all on a local repository. So how do we make this communicate with GitHub? So the way we would do that is we go to GitHub, we'd create a new repository, so a new repository, and we can name this repository anything we want. So I'll just call it Git example. I'll make it public because why not? And then I'll create a repository. You could add a README if you want. I don't really care enough to make a README. And if you just create without a README, it also tells you what to do. So that's just also why. So once you create a new repository, it's going to show up. It's going to basically display these steps for you. So I want to create a new repository on the command line, or I want to push an existing repository from the command line. So the difference is here is creating a new repository means that there's nothing in that repository. You have an empty file similar to, or an empty folder similar to what I have here. Pushing an existing repository means that you have your own file or your own folder where you have all these files and stuff. These would be the commands you'd use to basically push all those changes and make a repository and send it to GitHub without like uploading every single one using the GitHub website. So we already did our Git init. We could add a README, but I usually skip the step because I'm not a popular programmer, so no one ever looks at my code. So I usually don't add a README. But this is a very important this is a very important step right here, the git commit. So the git commit basically says save the changes I made to the local repository. So I can open up my Git terminal and I can do git status. And git status basically tells you the status of your repository. So it says I've never committed anything yet, and I have untracked files. So these are basically the files where they exist within the repository, but I haven't linked it or done anything to make it like do anything with GitHub. So the way you would do this is you would want to add it. So you could do git add and then the file name, but when you're working with a bunch of different files that you changed, you can usually just do like a period, because git add period or dot means add every single file that was untracked into my repository. So git add dot, and if I do git status now, it says I added a new file and now it's ready to commit. So now I can use this command. I can use git commit, and then the dash M is basically a flag to say message. So after the flag, you just say whatever you want your message to be. So similar to before, using the GitHub interface, we were able to like leave messages. Okay, I added more strecs to my files. This is the same thing. So I can say like first commit, because that's what they said. So we'll just do that. We'll just, because this is our first commit, so why not? So it made all these changes on the master branch. So 3 insertions because that's how many lines we added. So now we have to, this command basically says create a master branch, so make master. The thing is, if we look at git branch and look at the branches we currently have, so git branch and then the flag v for verbose, we can see that we already are on the master branch. The star basically means we're currently on the master branch, and this ID or this terminal basically tells you what your branch you're on. So I'm on master branch right now, and this is the next important command that you'd want to use, because this is what links your local repository to the GitHub website. So the repository that exists on GitHub, you want to make it like this is the GitHub, this is the repository that we have on GitHub. We want to basically use this command to link our repository that we just made on our own computer to that repository that we made on GitHub. So I copy pasted it. I could paste it and run it. So now git remote add origin. So now origin is basically the name of the reference to that repository. So I would use the git push command. So push basically means push the changes I made on my local repository to wherever I want to send it. So I want to push it to the origin. Origin is basically a variable name, if you could like call it, for this specific repository on GitHub. So I want to push that origin, and I want to push it on the master branch. So if I press that, it'll load a little bit. If this is your first time doing it, it's going to ask you to log into GitHub, but I've done this multiple times before, so it didn't ask me. But the good news is you only have to log in once, and it'll save everything. So you don't have to log in multiple times like you would if you maybe use a different terminal. So if I refresh this, I should have a different file in it, hello.txt. So that's pretty straightforward. I could do like something I previously did, like make a new branch, and you do this by doing git checkout, I think, or is it git branch checkout? We're gonna search that up right now. Git new branch command. Yeah, you do git checkout and then B. Okay, cool. So you do git checkout and then the flag B for branch. So check out this branch. So it literally means literally what it means. Like go check out this branch and move to a different branch. And if the branch doesn't exist, it'll create the branch for you. So I could say like my new branch. So I switched to a new branch. If you look here, you can see that I'm currently in my new branch. I can do the git branch verbose again to check if I'm currently on that branch. Yes, there's the asterisk, it's in green, cool. So then I could, I don't know, like touch new.txt, go back to my folder, like say whatever I want, save it, go back here, git add dot, git, and then git commit, message, added new stuff, and then I just do git push origin. This time I do my new branch. So that should push that to my new branch. I could obviously refresh it on GitHub and check the changes are obviously made. So that's pretty cool. I can switch between branches. So git check out master. I'm back on the master branch. You see the new just disappeared. Oh no, I want it back. Git check out my new branch. Switch to that, news back. You can make your changes. You can do everything just from terminal. Um, it's faster. So if you get tired using GitHub Desktop or you've been familiar with using terminal, this is another alternative. It's pretty fast. It's pretty convenient. If you want to do something you don't know, chances are you just have to go on the internet and search up. Like I want to do a git command for this. I want to merge. I want to do whatever. There'll be some like YouTube tutorial or article you can read. Basically, you know how when I made branches, I called them different names. There's a specific keyword in GitHub called GH pages. It's basically GitHub pages. And basically it allows for you to upload a HTML, JavaScript, CSS file, and it's smart enough to recognize those files and make its own like website. So basically, one cool thing I did with GitHub was I made a game for Philip, like this summer. So originally I made it in Python, right? Like I used Pygame, kind of scuffed, whatever, but I mean, it worked. It was pretty cool. Um, but then it turns out it didn't work. Well, it worked, like, but you'd have to install Python and Pygame and then run it, and it was inefficient basically. So a fix to that was by making it a JavaScript game, and the pros of making a JavaScript game that runs in your browser is that you could run it off of a website. So what I did was I made a HTML, JavaScript, CSS files, and I put it into a repository. And if you can see what the branch name here, it's literally GH pages. So you can look at the HTML, CSS. I'm sure you guys have taken some CS class, right? Like PCS or something. You guys learned this stuff. So I don't need to like say what it is. But basically, I made everything in JavaScript. So Sketch.js is I used the P5JS library to create all the visuals and all the movement stuff. So I did all of that, and I used GitHub Pages. So if you look here, it says environments, GitHub Pages active. So I click on that. Psych, not this one. If I click on settings, I believe, it'll tell you where it is. It will tell you right here. Your site is published at, it's going to usually be your username, github.io, and your repository name. So if I click on this, it'll take me to the website where all my files get run off GitHub servers. So it's loading a little bit because, yeah, but there it is. So I made this game. Min helped me make the stuff. It's pretty cool. So this just goes to show what you can do with GitHub. It's not only just like a version control software, but you can also host websites. That's pretty cool. So if you guys ever want to like work on projects where you, I don't know, like build stuff or like make websites, you can use GitHub. If you want to make a JavaScript game, like learn how to use the P5JS library or other libraries, there's a lot of JavaScript libraries, you can just use GitHub Pages. So you can make pretty cool games like this. It's pretty cool. And then lose this and then play again. It's pretty cool. So that's that. Okay, I think that's all I had to talk about. So